All right, we come to the final section of Chapter 2. It's called Compound Inequalities. So we learned about them last time. Compound inequalities. We learned about inequalities in the previous section, Section 8. And now we're going to go to compound inequalities. What does that really mean? It means you have two inequalities that are joined together, and you can join them together either by the word and or by the word or. So and or, and these guys are going to be very different from each other. So let's take a look at this one. Let's take a look at example 1 from the textbook, and we'll kind of see. So first things first, you got to know that this guy is an or statement, which is going to look a little bit different from an and statement. All right. So we are going to graph the solution to this right here. Compound inequalities, they're pretty cool. Because if you're like testing, let's say you're testing temperature and you're testing pressure. So you have liquid nitrogen that is somewhere in a vat. And so you're going to keep tabs on, first one is the temperature. And then you're also going to keep tabs on pressure at the same time. And that's kind of what these are saying. You're looking at two things at once, making sure both are in the correct level. All right, so joined by the word or. Let's go for it here. So the best way to do it is think about the fact is I'm going to graph x less than -1 on a graph over here. So there it is. We're going to put a open dot at -1, and the word x less than means we're going to go to the left. So notice the first one is starting at -1, going off to the left. All right, next one is going to be x greater than or equal to 3. And greater than or equal to 3 means I have a closed dot at 3. And we go off to the right. Now, we learned those two things last time. Here's the new stuff that we have not learned. We're going to combine these together with the word or. Now, the word or just means you have at least one answer. So the question, if you go down here, is there at least one answer at -2? Yes, it's from the top one. Is there at least one answer from -3? Yes, the top one. Is there at least one answer at 0? No, because none of them were true. And is there at least one answer at 4? Yes, the bottom one is true for that. So it's almost like if you think about it, just kind of sandwich these guys together. You're sandwiching these guys together, and you're making one graph out of 2. So there it is. There's your final answer right there. The graph is given. All right, so let's try some example problems here. So we're going to graph x less than -3 or x greater than or equal to 4. Let's go for it. Very similar to example number 1. Let's jam with it here. So x less than -3. You go with me if you can. You can go ahead of me if you like. So let's go for it here. So looking at this right here, graphing x less than -3. I'm going to put -3 over here, kind of a little bit off to the left because I know my other ones are going to be somewhere over here in this area here. So -3, I have an open dot because it's less than, and I'm going to go off to the left. So I usually shade all the way to the end, and then this little arrow I'm going to make a little bit bigger. And that's kind of, you're supposed to be doing that because you're saying it's going to keep on going. All right, give you guys a little time. Finish graphing that. All right, let's graph the next one here. X greater than or equal to 4. So if that is the case, x greater than or equal to 4 means I have a graph. 4 is a little bit off to the right-hand side. Open dot or closed dot? What do you guys say? Open dot, closed dot? Closed dot it is, all right. With the closed dot, we're going to go to the right this time, and we're going to fill in that little 0. And just like we did before, right here, now we're going to graph the whole thing. And the whole thing is just these two sandwiched together. That's what or means. That means the solution set to this or this means it goes off to the left or it goes off to the right, but it does not meet in the middle. All right, a few little things here. This is called a graph of the set. I want to teach you here something called interval notation, because interval notation, that's the kind of like the new way we're doing things now in mathematics. So if you're going to do this by interval notation, you're going to say this. The solution set to this is starting off at -infinity, moving across all the way to -3, and we're going to have a parenthesis. Whenever you have an open dot, you have parentheses. All right, the new stuff. I learned this in the last section as well, right? If you have a gap between your answer, you're going to write the letter U. It's a big O capital U, and that stands for union. Union. Whenever you have a closed dot, you're always going to use brackets. Brackets with the 4 inside it and goes off to positive infinity. So there's your final answer for that. All right, if you want to write this on the side here, go for it. Open dots means you have parentheses, kind of depending which way you're going. So in this case, notice we're going off to the left. So it's a parenthesis that opens to the left. This one was a 4 that was going off to the right. It was a closed dot, so therefore we had a bracket to the right, opening to the right with the 4 inside there. All right, waiting for you guys to finish, and I think everybody's done. Let's go on to the next one here. So that was the OR statement. So let's jump and figure out why is the AND statement different, and how do you graph it differently as well. So let's do the exact same thing, and we'll see a slight little difference between the OR and the AND. So x greater than or equal to -1. Let you guys graph it. In fact, here, you guys graph those two right here. X greater than or equal to -1. And x less than 5. Give you guys a little bit of time. I'm going to pause the recording here. All right, back together here. Let's go for it. So hopefully you put this down. -1. Open dot or closed dot? Closed dot. Going off to the x greater than or equal to -1. That's going off to the right this time. Don't forget the arrow. Hopefully you guys didn't miss the arrow. The next one is going to be x less than 5. So let's do that. You guys have already have it down on your sheet of paper. That's cool. Open dot is correct. And x less than 5 means you're going off to the left side. Arrow made bigger. Okay, now here it is. I'm going to write this all together now. This is the AND statement. That means that this has to be true and this has to be true. Both of them have to be true at the same time. So it's almost like the pressure has to be above this and the temperature has to be below this, if we're using our little analogy there. And when you graph it, it looks like this. So notice right over here, only one of them is true. Right here in the middle, both of them are true, and that's exactly which one you want to AND statement. When are both true? And after this, none, they're not both true. So it's almost like this. For the AND statement, if you were going to sandwich these guys together, it's going to be where they meet, where they connect to each other, and they connect to each other right in the middle there. Boom. All right, let's go for it. How do we write this in interval notation? Well, we have a closed dot, which means, anybody? Bracket. Opening up -1, comma, it's a bracket opening to the right, and we go all the way up to 5, and because it is a parenthesis, we have ourselves because the open dot, we have ourselves a parenthesis. Okay, we're good there. Number 2 is solved. All right, so that was the basic. We just got the basics. We just figured out, well, how to graph these. What is an OR statement? Again, it's a gap in the middle going off separate directions. An AND statement is where they connect together. It's usually the middle is filled in. Now let's do some problems. All right, solve this. So the first thing we should recognize is there's an AND statement. So when we're going to be putting this together, we're going to see where they connect to each other. Where they connect to each other. All right, so let's go for it here. A little bit of work to do now. So I'm going to add 1 to both of these guys right here. So I have to work 2 inequality problems first. So 3x minus 1 greater than or equal to 8. I'm going to add 1 to both sides. Gets you a 3x greater than or equal to 9. That's cool. I think you guys know what to do here. Divide by 3, and voila. We get ourselves an answer called x greater than or equal to 3. Awesomeness. All right, careful with the next one. It's a little bit tricky one. Over here, we're going to divide by -4, good. And then something happens when you divide by a negative. All of a sudden, some weird stuff happens. It's made by this little sort of curly or curvy arrow. Yes, so we have to flip the inequality, and -24 divided by -4 is +6. And let's see how we can graph these guys. Okay, first things first, x greater than or equal to 3. There's that. It's a closed dot. Yes, that is true. And we're going to go off to the right. Perfect. That's the first one. That's the connection right here between these guys. All right. And then we have x less than 6. Now we have a 6 over here. Open out, close dot. Open out. Perfect. Off to the left. And make arrow bigger. And Again, it's an AND statement. AND statement is what's the final graph? What combines both of these together into one statement? So we have a graph that starts at 3, including the 3, goes up to 6. So starts at 3, including the 3, and then goes all the way to 6, but does not include the 6. That's what the open out means. We don't include 6. And we shade in the middle because that's where they connect. Perfect. Anybody got interval notation? Cool. All right. Bracket 3, parenthesis 6, or 6 parenthesis. Sorry. Bracket 3, comma 6 parenthesis. All right. Now, we don't spend too much on OR statements because they're fairly simple. They're just going to go one direction, another direction. Ta-da! You're done. AND statements, that's what we spend it on. And then, so that's why number 3 was an AND statement. Number 4 is also an AND statement. And we actually call this something called short notation for AND. Before I do that. So you guys will see this in the math textbook because this is called short notation for AND. So it is going to bunch up in the middle, but notice our variable is already in the middle. That's kind of what it means. It means like this section here, this variable, whatever the multiplier is, whatever the addition is caught between a -7 and a 17. That's kind of what we're looking at right there. So the question is, how do we solve short notation for AND? Short notation for AND, well, what we're going to do, notice there's kind of like 3 different sides. There's the left side of our inequality, there's the middle of our inequality, and then there's the right side of our inequality. So what we're going to do is we're going to try to get this guy down to 0. So 3x plus 2. Question is, what are you going to do here to get this guy down to at least a 3x? Of course, we're going to subtract 2 to get rid of this positive 2. But since there's 3 sides to everything here, what we have to do here is we have to subtract 2 from all 3 sides. So -7 minus 2, -9. Bring down the inequality. These 2's cancel, so we're just left with a 3x. 17 minus 2 is 15. Perfect. Okay, next, what are we going to do with the 3x to get it just down to an x? Perfect. Divide by 3 is perfect. Divided by 3, -9 divided by 3 is a -3. This comes down. 3's and 3's cancel. This comes down, and 15 divided by 3 is a 5. Boom, there it is. Now, the cool thing about short notation, you don't have to do 3 separate graphs. You are done. This actually tells you exactly what to do. It says this, and let me read it to you just in case it makes a little sense here. You're saying -3, the number that you want is less than or equal, -3 is less than or equal to the number that you want, and the number that you want is less than or equal to 5. So x is caught between sort of this -3 and +5. All right, what does the graph look like? Here it is. -3 on one end, 5 on the other. We've got a closed dot at -3, a closed dot at 5, and we got everything in the middle. There it is. X is somewhere gauged between those 2 numbers. All right, interval notation, go for it. What do we got? Interval notation. Bracket -3, because the closed dot, comma, and 5 with a bracket going to the left. So there it is, bracketed on both sides, and done. All right, so the question comes up is, Mr. H, how is it that the AND statement is kind of like the same as this right here? How could x greater than or equal to 3, -3, and x less than or equal to 5 be the same as this short notation? So we call this long notation right here. And we call this short notation. So I'm going to try to change this long notation into the short notation. All right, if you don't get this part of the PowerPoint slides, that's okay, as long as you can work out the short notation. But those that are curious, let's go for it here. So what I'm going to do here, I'm going to switch these 2 around. So -3 is going to go to the left, and the x goes to the right. And whenever you switch these around, you have to switch the inequality as well. Okay, so notice what it says. It says -3 is less than or equal to x, and x is less than or equal to 5. So notice these are redundant right here. So x is here, and this is the relationship. So whenever that happens, this little and combines these guys together into one little statement. And so there it is. There's your long notation converted to your short notation. And that's why this guy is funny. Because some students say, Mr. H, that's kind of a funny way of saying it. But let me say it in English. Let's see if it makes sense. -3 is less than the number that I want. And the number that I want is less than 5. And so it makes, as you read it in English, it makes perfect sense as you're talking about the number that you want. All right, and the graph, just like in the previous slide, exact same thing. There it is, bracket notation, or bracket for interval notation. All right, then I made up my own little problem, just for you guys to solve here. Again, I'm going to pause the recording. I'll let you guys solve it. We'll get back to the recording. So can you solve this from beginning to end? All right. Hopefully you guys have solved it. Let's go for it here. So hopefully you added 3 to both sides here. And we get ourselves an 11. Divide by 2, and we get ourselves a fraction. Well, what do you know? 11 halves. You're going to have this on the homework as well, so might as well do it now. On here, we're going to be subtracting 1 from both sides. So 3x greater than -11 as well. Well, opposite of that, that's okay. Divide by 3, and again, we got ourselves a fraction. Okay, so now the question is, how do you graph these? And so as you graph them on your homework, you just need to tell where one is. And then think about 2 goes in 11. What's that? 5? 5 times and a half left over. Is that right? It's off to the side. You need to sort of just gauge where this is at. 2 goes into 11 5 times, and 1 left over. So that's how we think of that number. And then we have -11/3. Let's see where that looks like. It's a negative, first of all. 3 goes into 11. 3 times 3. So that's 3 times. That's 9. 3 and 2/3. So there's that number. Just for you to sort of see where each of those pieces are. There it is. All right, let's go for it. There's that one. And then we're going off to the left. Graphing the other one. That's a -11/3 now. Going off to the left. No, the right. Okay, good. It's an and statement. So can you put it together? So there it is. Comes down. Open dot. Open dot. And then it's bunched up right in the middle. All right, and if you haven't, give the interval notation. Go for it. Give the interval notation with it. It's open dots on both ends. So parentheses -11/3, comma, +11 halves, close parenthesis. All right, another one. Last one here, I think. I think it's the last one here. All yours. I'm going to pause the recording, let you guys finish it off. Go for it. For you that are watching the video, you guys pause the video, try it yourself, and then come back to the recording. All right, let's go for it. See, most of you guys are done here already. So let's subtract 9s from both sides. Gets us a -2. Divide by 3, and voila. Gives us x is less than -2/3. Got some fractions here. That's okay. On the other side, we're going to add 7 to both sides. Gets us an 18. Divide by 2, voila. And 18 divided by 2 is a 9. So there it is. It's an or statement this time, right? So think about the or. -2/3 is over here. I got myself an open dot, and going off to the left, underneath it, I got myself a value at 9, and that's going to be an open dot going off to the right this time, and that's exactly how an or statement should look like. So I'm assuming that you guys have it done. You're just correcting your work here. There's your or graph. Now, interval notation. For those of you that haven't done it yet, go. All right, so parentheses, -infinity, all the way up to -2/3 in another parenthesis because it's a open dot. What do we do again over here? Or if there's a gap for our answer? Yes, union, or capital U. Starting off at 9, parenthesis, because of the open, and then going off to +infinity. There it is. Oh, no, it wasn't the last one. Shucks, there's another one here. All right. Another one, go for it. Can you just practice this one all the way through? Again, pausing the recording. You that are watching it by video, pause the video itself and try it yourself first. All right, so we're back. Let's go for it here. So hopefully you guys, most of you guys have done this already here. So we're going to subtract 5 from all 3 sides this time. So how about a -6? 4x is in the middle now, and how about a 4 on that side? Dividing everything by 4, or all 3 sides by 4. And this one you can reduce down to a -3/2. That's an x now, and 4 divided by 4 is a 1, so there it is. This is short notation. Remember, you don't have to do 3 graphs anymore. You're just going to get a graph that's caught between -3/2 and 1. Both are closed dots, and we got ourselves a everything caught in the middle. Okay, interval notation, go for it. So bracket now, -3/2, and we're going all the way up to 1 with a bracket there because of the closed dots. Closed dots mean brackets, open dots mean parentheses.